This is a short video to support your Quickwrite 2 assignment. And in this video, what I'm going to do is go through a couple of maps. What I want to introduce to you is elements of maps, how to read them critically, and in some respects, how to look at what you're going to be seeing in the media over the course of this semester, and also in terms of what's really going on in the world today. So let's begin first by, I want to talk a little bit about what we mean by this. And what I mean when I say a map element is a piece of a map that carries some important information. So oftentimes you'll hear me talk about map elements, and those elements are the things that we want to understand. All right, so here are the ones we're going to talk about. Scale, enumeration units, the variables presented on the map, the way that the variables are classified, or the classification method, and then the concept of normalization. So let me quickly go through these in terms of definitions, and then we'll look at some examples. So let's begin with the question of scale. When we talk about scale on a map, what we mean is the relationship between how the map visualizes the world and real world distances or areas. So for example, you might see a scale on a map that says 1 inch equals 1 mile. Well, what that means is an inch on the map is equal to a mile in the real world. We'll sometimes see that listed as simply a fraction, 1 with a colon or a line, to say 5,000. And again, what that would mean is 1 unit on the map is equal to 5,000 units in the real world. So 1 inch on the map is equal to 5,000 inches in the real world. And so that's what we call sometimes a unitless scale. One of the important things about scale, though, is as a map shows more and more of the world, the detail decreases. So if we want to see a lot of detail, we can only show a small area. If we want to show a really big area, we tend to lose a lot of detail. And the next idea is what we call an enumeration unit. And this goes with variables. So the variable, and we'll kind of put these two together, a variable means simply what are we mapping? Are we mapping tornadoes? Are we mapping coronavirus? Are we mapping crime? Those are variables. And in some aspect, we want to talk about those. When we talk about enumeration units, though, most of the time when we count something, we're counting the number of times something occurred within a specified area. So how many crimes per block? How many tornadoes per state in a given year? How many deaths via the coronavirus by county or state or country? In that case, the enumeration unit matters because it defines for us the area that number is related to, and oftentimes has some reference to the population. Now, classification means how we classify or order the variable in terms of its numbers or some other way. And so we may see that classifications are rankings of things. And again, we'll give some examples of that. Or it might be simply the number of occurrences. So 1 to 5 occurrences gets one color or one size symbol. Another one, 5 to 10, gets another size or color. And so classifications work that way. And we have to be careful because not all classifications are what we call equal. Sometimes they are not equal for very good reasons. And as the semester progresses, I'll probably introduce a couple of those to you. Now, the last term here is normalization. And this has become very, very important when we talk about things like the coronavirus pandemic. Normalization means how to compare what we do something to normalize or to make two different enumeration units comparable. Okay, so normalization means to make them comparable. As an example, if I compare the total number of virus deaths in the United States versus Germany, there's kind of a problem because there's simply more people in the United States. And so what we then would typically do is we would divide the number of deaths by the total population. That's a form of normalization, because once we divide it by the total population, then we can compare Germany to the United States on a per capita or per person basis. So let's take a couple examples here, and I want to go through some of these things so you can see them. So first, this is what I pulled off the Chicago Tribune. It's a very simple map, probably one of the simplest you can imagine. And this has to do with what has been happening over the last couple of days. And these are mapping protests, looting, and unrest. Now, the problem with this map is that when we say variable, we have, according to this, protests, lootings, and unrest. Well, what do these dots represent? We don't really know. But that is the variables, and sometimes our variables are rather mixed. In this case, the scale, it's a rather large area of Chicago that's being shown. There's a fair amount of detail. You can see the blocks, but we lose some of the detail as to where these things are actually occurring because they need to show the whole city. All right, I'm going to get out of this for a minute, and we're going to look at a couple of other maps. All right, so for example, if we look at the coronavirus map, this is kind of one of the more classic examples. What we can see here, again, and I want to think about all of the pieces we have here. Now, in this case, the enumeration unit is countries. You'll notice that every country has a dot in it. And we're also going to talk about normalization. So you'll notice here, in the United States, we have almost 8 million cases. But we've normalized it by share of the population. So 1 in 182 people have been diagnosed with the disease. Now, if we compare that, let's go over to the United Kingdom. And again, remember, we have almost 1.8 million cases. The United Kingdom only has 274,000 cases. But let's take a look at it from the standpoint of normalization. Again, just over 250,000 cases, 1 in 242 people. Here, 1 in 182 people. So, in fact, the United States and the UK have somewhat similar numbers in terms of their rate of cases, while the total number of cases is very, very different. And similarly, we can look at Russia. Again, cases just under 500,000, but its normalized value would be 1 in 348. So normalization often allows us to more accurately compare two areas. The other thing that we should consider is how this idea of the unit, the enumeration unit, changes things. So I'm going to scroll down here, and we're going to look at this in terms of the United States. And so if we look at the U.S. coronavirus map, get this one to come up. What we can see, kind of scroll down to this for a minute. Yep. Okay, so now we're going to look at it with a different enumeration unit. Now, it's important to understand enumeration units really change how we see data. Right here, what you'll notice is that we actually have all of the United States, but the data is not by state, but rather by county. So in this case, the enumeration unit is a county, and again, rather than using a dot that gets bigger or smaller as our symbol, we're actually using color codes. And if I were to move up a little bit on this, you'll see that in this case, it's an interesting idea. They're not using a classification that is numeric. They're simply saying whether it's rising, falling, or about the same. So classifications can also be kind of qualitative rather than numeric. Now let's take a look at it. I'm going to change this to total cases. And again, in this case now it is numeric, and what we show here is a little dot, little circle is 100, and a big dot is 10,000. And in some cases the dots get really, really big, and that the dot, or the circle, is proportional to the quantity. So that's another way of classifying our data. Now you'll notice here, anytime you see per capita, that is a form of normalization. So again, 1 in 200, 1 in 100, 1 in 30. Those are normalizations so that we can compare counties that have large populations to counties that have small populations. Okay, now the last thing I want to do is I'm going to ask you to do a little bit of thinking here, and I'm going to bring up a very different type of map. And so, of course, many of you, I'm sure, have heard of all of the protests that have been going on in the United States, and that the question of the relationship between the protests and police violence, race in the United States. And it is important to understand that now what geographers really do is we bring together the distribution of what's, and we ask questions about why. And so here's what I want to do with this map. I'm going to walk through a map, and we're going to talk about each of the elements that we've had so far, and we're going to think about what they mean. So if we look at this map right now, and I'm going to minimize some of these classifications. If we look at this right now, all that we are looking at is at a census tract, which is a rather small level enumeration. This is the number of people per square mile. Now, what we can see, again, darker color is higher. So we have very, very high population densities through here. This is Minneapolis and St. Paul. And so we see this very, very high level. What that allows us then to say, and I'm going to turn this on, and you're going to see a slightly different way of seeing data. And what we have now is police actions in this area. And so what I want to do is what we were going to call police stops. And so if I turn on police stops, it'll take just a minute for it to draw. And what this shows you is something called a heat map. And so when we have a whole lot of data, we sometimes actually take away the quantity, the actual locations, and we say that it is either sparse or dense. And so police stops, it makes sense to say that the police stops, and you can see this pattern through here, makes sense based on where the population density is highest. You're going to have more stops where there are more people. But the other issue, of course, that comes into play is police use of force. Now, one would expect that instances of police use of force should parallel the number of stops. In other words, if you're going to have more stops, you're going to have more of these incidents. And if we bring that up, this is the use of force. And you'll notice that we have, again, to some degree, this density of force here. But what I've done with the police use of force is I've asked the question of what kind of force. And the issue that brought much of what's happened to the fore is the use of extreme or maximal restraint techniques. And what you will see, again, these are the red dots, you can see that they are also occurring where that high density is, but they're actually occurring quite a number of other places. So we begin to ask the question, why? And what geographers ask is, what are relationships? Not causations necessarily, but we begin with relationships. And I'm going to turn off that. And now what I'm going to add on to the map is the issue first of race. And what we have to be careful with this, and I'm going to turn off so you can see kind of what we're looking at here. Race in Minneapolis, and again, I'm going to expand the legend so that you understand this. When we look at race, what we are saying at the county level is two things. Actually, I'm going to get this all the way down to tract level. So what we see about Minneapolis is that much of the area surrounding Minneapolis is predominantly white. And you'll notice that the intensity of the colors means the strength of predominance. And so what we see though here now is that we have areas of very, very high predominance African American populations. Then we have a Hispanic and Latino population here. And then we have some other populations way over here towards the St. Paul area. Now, the question that bears asking is, I'm going to turn on the police use of force. And what you're going to notice is that there is some correlation here and here. In other words, the two things co-occur. So when we look at maps, it's important to ask these questions. And I'm not even going to begin to address the challenges that are facing our country in terms of policing, violence, and the use of lethal force. But what I want to suggest is that geography has a role to play in understanding the relationship between these things. So what I've done here is I've given you some of the examples. This is what you will use. You are going to find your own map online, and you're going to begin to explore it based on these questions. We'll see you next time.